Bismillah, Bismillah, au nom d'Allah, Bismillah.
Hello students, welcome to our chemistry class, and our topic today is thermochemistry. The subtopic is determination of the enthalpy of combustion of ethanol, the enthalpy change for the combustion of ethanol. Now, this is our 12th lesson in this e-learning process, and today we are going to determine the enthalpy of combustion of ethanol. Now, the objective of our learning today is that at the end of this experiment, you as a learner should be able to carry out an experiment to determine the enthalpy of combustion of ethanol. Enthalpy of combustion of ethanol. Now, we are going to carry out an experiment. And the requirements: we need ethanol. My ethanol already has been filled in this spirit lamp. So I have a spirit lamp here with ethanol, half filled with ethanol. Then we need a 250 ml glass beaker. We need a glass beaker. This is my glass beaker. Then we need a tripod stand. My stand is here. The tripod stand. We need a wire gauze. This is my wire gauze. We also need a matchbox just for lighting our spirit lamp. Then we also need a cardboard screen. This is my cardboard screen. Another thing that we need is a 100 ml measuring cylinder. Then I have my thermometer here with me. Another thing that I should be also having is distilled water in a wash bottle, and then my electronic balance to measure the mass. That is my electronic balance. Now, those are the things that we are going to use in our study today to determine the enthalpy of combustion of ethanol. Now, our first procedure is to pour exactly 100 centimeters cubic of distilled water into a 250 ml glass beaker. So we are going to measure, we need to measure volume. So we measure 100 centimeters cubic of distilled water. Yes. So the volume that we have here, with that, the volume that we have here is 100 ml. Record the temperature of the water. So this is my thermometer, and we need to record the temperature of the water. So this water, give it some time, then we record its temperature. From my thermometer, it is 26 degrees. So I will note the temperature of the water, which is the original temperature of water, to be 26 degrees Celsius. Now, that one will take us to this table. So I will have my table here so that I will use it later. Now I will have the volume of water in the beaker. Then I will have the initial mass plus of water initial mass of bottle plus its contents. which should be original mass. Then the final mass of the bottle plus contents. This one will be W2. Mass of ethanol, we have mass of ethanol. Burnt, which will be W2 minus W1. Then initial mass of water, initial temperature, of water. Then the final temperature of water. Then we'll have change in temperature. So those are the things, the information that we are going to collect during this experiment. Now we have measured the initial temperature of water, and it is 26 degrees Celsius. Now let's go back to our procedure. Now, then the next procedure after recording the temperature of water, then we need to half fill the spirit lamp with ethanol. Already we have done that. We have our spirit lamp, we can call it, it's what we call there as a bottle. And it is a half filled with ethanol. Then number 3, weigh the bottle and its contents. So I have my electronic balance here, and I'm going to put it on and then zero it. For that, I will take my spirit lamp, half filled with ethanol, then weigh it. So from here it is 169.73. So the initial mass of the bottle plus its contents is 169.73 grams. That's what we have. Then we move to step 4. In step 4, we are told light the wick to start heating the water. Stir the water carefully with the thermometer and extinguish the flame when the temperature of the water has risen by 15 degrees Celsius. So we are going to heat. Now, I will remove the cap and place my spirit lamp here. Then have my wire gauze, the beaker, my 100 ml water. Then I'm going to protect my setup from drought. Drought is wind. Direct wind, beat like that. Then next thing I'm going to do is now to light that wick. Remember our original temperature is 26 degrees Celsius. We're supposed to allow the temperature to rise by 15 degrees Celsius. So that is what we have. So I will block it to reduce the effect of drought. Drought is wind, like that. Then we'll allow heating to take place. But the temperature must rise by around 15 degrees Celsius. So let's see. The temperature is supposed to rise by 15 degrees. So if our original is 26, Then if you add around 15, must be, we'll have around 41. So we'll require the temperature to be around 41 degrees Celsius, then we stop heating. That's what we are going to do. About to reach 41, it is now 38. Our temperature is now 38 degrees Celsius. It's about 40, around 39 there. So the ethanol is burning, and that heat from the ethanol is transferred to the water. Ethanol is burning and the heat is transferred to the water. The heat is transferred to the water. Yes, now my temperature is 42. Now we can stop heating. And after heating, so what next? We are told allow the lamp to cool, so we are going to put it off. We are going to put it off as we record the final temperature, which is 41, 2, 3. So this is our lamp, we put it off and we allow it to cool. As we record the final temperature of the water is 43 degrees Celsius. That is our final temperature of the water. Remember, the volume of water was 100 centimeters cubic. The volume of water was 100 centimeters cubic. The initial mass, which is the original mass of this bottle, we got to be 169.73. Now, so allow the lamp, we're back here, allow the lamp to cool and reweigh the spirit lamp and its contents. So this is our lamp, we are going to reweigh it. Now it is 115.53. 115.53. 115.53 grams. Yes, so that is the data that we have. That is the data that we have. Now, we don't need these things. We are going to move into answering the questions. So, after doing all this, now let's see what we are required. Questions. Let's see the questions that we are supposed to answer. The questions that we are supposed to answer. Now, the first question, we are told to calculate the temperature change. Calculate the temperature change. Calculate the temperature change. That is our first question. So I'm going to note down the final mass, our final mass to be 1 gram. Our initial mass to be 169.73. Now, so the temperature change, that is question 1, part A, the temperature change delta T will be the final 43 minus initial, which is 26. That will give us the temperature change. So 43 minus 26, we have 17 degrees Celsius. So our temperature change is 17 degrees Celsius. That is question A. Question B, the mass of water heated. The mass of water heated. Mass of water heated. Mass of water heated. So the mass of water is equal to density times volume. Density times volume. Density of water, last time we said, is 1 gram per centimeter cubic. The density of water is given as 1 grams per centimeter cubic. So it is 1 times the volume of water, which is 100. We get 100 grams of water. So question B, which is the mass of water heated, taking density to be 1 gram per centimeter cubic, will give you 100 grams of water. Then we move to the mass of ethanol burnt. The mass of ethanol burnt. Remember, we took this bottle. We had the original mass of the bottle plus its contents, which was 169.73 grams. After burning, the mass came to 115.53. So when calculating the mass of ethanol, that is part C. Yes, so in part C, we are supposed to calculate the mass of the ethanol that was burnt. Mass of ethanol that was burnt. And we need to go back to our data. And in our data, the data that we have collected, that is the data, we have the mass, the initial mass of the bottle plus its contents, and then the final mass of the bottle plus its contents. So for us to get the mass of ethanol, we'll take the final, which is 169, the initial, 169.73 minus 115.53. Very, very fast, so that we don't waste time. It is 169.73 minus 115.53. So the mass of ethanol burnt was 54.2 grams. 54.2 grams. I will move on. Now the next thing we are asked is to calculate the heat change that occurred given the specific heat capacity. This capital C stands for specific heat capacity, to be 4.2 kilojoules per kilogram per Kelvin. And last time I said, if this specific heat capacity is per kilogram, then our mass must be in kilograms, so that the two values must agree. Remember, the heat from the ethanol, which was here, was being transferred to the water. So the temperature change was the temperature of the water, not the temperature of the ethanol. That's why we are not going to use the mass of ethanol here, but we are going to use the mass of water. Why? This temperature change is the temperature of the water in the beaker, not the temperature of the ethanol. So you should take note of that. Then now say that part E, heat change, that is change, enthalpy change, should be mass times specific heat capacity times change in temperature delta T. The mass is the mass of water, which is 100, and it must be in kilograms. Then times specific heat capacity, which is given as 4.2, times 17 degrees Celsius times 17 degrees Celsius. So we are going to have 0.1 times 4.2 times 17, then we have 7.14. So this one will give us 7.14 kilojoules. This K must be a small k, J must be capital J. Now, very important point here. Let us come back, because this change can either be exothermic or endothermic. And at this point, we must decide whether we are going to give it a negative for exothermic or a positive for endothermic. Now, for us to decide that, we come back to change in temperature. Remember, the temperature was 26 degrees. That's the original temperature of water. And then later, the temperature rose to 43. That rise in temperature means as the ethanol was burning, heat was being released. So a rise in temperature indicates an exothermic process. Therefore, this value must be given a negative, showing that it is exothermic. Without this sign, you will get half a mark for working this, but it remains the mark for the answer. So you must put that one there. Now, the next thing, which is part E. Part E, they're asking us to calculate the moles of ethanol burnt. That is part E. Moles of ethanol. We know that moles is equal to mass over RFM, the number of moles of a compound. Do we have the mass of ethanol burnt? Yes, it is here. Do we have the RFM? We can come up with the RFM of ethanol. So the RFM of ethanol, you add the relative atomic masses of the atoms that constitute the ethanol as a compound. So we have carbon is 12, and we are given those values there, and we have 2 carbon atoms plus hydrogen. How many atoms? 5 plus 1? 6 atoms times 1. You still have 6 plus. Oxygen is 1 atom times 16. Now we'll have 20 what? 24 plus 6 plus 16. We have 46. So the relative atomic mass is 46. Now we come to moles of ethanol, which is the mass of ethanol burnt. Mass of ethanol burnt divided by the RFM, which is 46. Very, very fast. We'll have 54.2 divided by 46. We have 1.1 1.17, and always correct moles to 4 decimal places. So 1.17826. 172 1.1782 like that, moles. So we have burned a lot of moles. That's the number of moles. Make sure the moles is in 4 decimal places, that digit. Now, number F, the molar enthalpy of combustion. Molar enthalpy of combustion. Molar enthalpy of combustion means the heat change that occurs when 1 mole of ethanol is burned. When 1 mole of ethanol is burned. So if 1.1782 moles of ethanol was giving us negative 7.14 kilojoules. What about 1 mole? So 1 mole will be 1 times negative 7.14 divided by 1.1782. So for 1 mole, we'll have that is 17.14 divided by the answer we get 6.059. This one will give us 6.079, and this is a negative. So this is kilojoules per mole. Kilojoules per mole. So that is the molar enthalpy of combustion for burning 1 mole of ethanol. Then we are told to write the thermochemical equation. That is equation 2. Write the thermochemical equation. Thermochemical equation is now ethanol, which is C2H5OH, burning in oxygen, and normally when organic substances burn in air, they give you carbon dioxide plus water. Now, this thing must be balanced. We have 2 carbon, 6 hydrogen, 6 hydrogen. We must maintain 1 mole because we are talking of per mole. So there's no way we can have 2 here. That one will not be per mole. Per mole burning 1 ethanol. So we must maintain 1 mole on this side. Let us balance oxygen. We have 1 oxygen plus 2. Those are 3. This side we have 2 times 2, 4 oxygen plus 3. These are 7 oxygen. So to maintain this number, there's 1 already here, so we need 6. 3 times 2 is 6, plus 1 is 7. We have a liquid, a gas. This one you can either give it a liquid state or a gas state in form of steam. Let's give it a liquid. Then delta H should be negative 6 points. This value here, 0.079 kilojoules per mole. So this one is what we call thermochemical equation, showing the heat change at the end. That's what we call thermochemical equation. The next thing is to draw the energy level diagram. Draw the energy level diagram. That one I will leave for you as an assignment, because we have done it for the other experiments. Make sure you do that. You draw the energy level diagram and submit it for marking. Now, there's this question which we are told as number 4. We are told, state the reason why the value of the enthalpy obtained in the experiment is slightly lower than the actual value. So this question is asking us, if you compare the theoretical value and this one, you find that what we have here is lower. This question is testing on the sources of errors. the sources of errors. And we have several sources of errors. One source of error is loss of heat to the surrounding. Remember, we were just burning this thing, and we are not sure whether all the heat from the ethanol that was burning was transferred to the water. So some heat energy got lost in the surrounding air. So that one introduced a source of error. The second source of error, why this value will be lower than the theoretical value, is some heat is absorbed by the container. So this container, the beaker, also absorbs heat. Even the wires also absorbs heat. So there is that heat which is lost in the process. And the third source of error is some ethanol evaporates during the cooling of the spirit lamp. We were told to cool, allow this spirit lamp to cool, then reweigh. In the process of cooling, ethanol is volatile. So a lot of it was lost in the process of cooling before weighing. That is also a source of error. Then finally, there is incomplete combustion. So during burning of ethanol, we saw some yellow flame, a mixture of blue and yellow flame. The yellow flame indicates that the ethanol molecules underwent, some of the molecules did not burn completely, leading to the presence of unburnt carbon particles in the flame, which caused that yellow flame. So there was incomplete combustion, and we know when something undergoes incomplete combustion, the amount of heat released is lower than the expected. So again, that is also a source of error. And now, to define, our aim was to get the enthalpy of combustion of ethanol. But now, what is this molar enthalpy of combustion of ethanol, which we have calculated here? It is simply the enthalpy change, or the heat change that occurs when 1 mole of a substance burns completely in air. The heat change that occurs when 1 mole of a substance burns completely in air. That's what we call the molar enthalpy change. And that's why we had to calculate the heat change for 1 mole. That one brings us to the end of our lesson today. And I will send you some questions so that you can work them out, and in the process you will understand the concept better. Otherwise, thank you for listening. Let us meet next time to look at another aspect of enthalpy change, or change in energy.
Bismillah.